Hello everyone. Today we are going to talk about AI agents. We will talk about the agents in 5 sections. We will talk about what the agents are. We will talk about how they are behaving or how they should behave. In the section 3, we will talk about tools and actions like how ChatGPT is creating images. And in the section 4, we will talk about agent workflow like how an agent thinks and observes. And in the last section, we will talk about and we will create our first dummy agent. And I will explain why it is dummy in detail later. So let's start with the section 1. So what is an agent? When I first learned about the agent, I just thought it is a cool name, like agent. It is doing something cool, so that's why it is an agent or something like that. But it is not. An AI model capable of reasoning, like planning and interacting with its environment is called agent, like ChatGPT. LLMs are actually just extract or generate texts. But when I ask a ChatGPT or Hugging Face GPT, Hugging GPT to create an image, they can because they have a create image tool. Like they can create image while asking some another agent. So it is an agent because it has agency, aka it can interact with the environment. That's why it is called agent. So in basic, when we give a request to the agent, it thinks and plans. It is a reasoning section. Maybe if you are using like Sonnet 3.7 or DeepSeek, you can see the thinking section. This is actually that section. And it thinks about if I can use a tool, like maybe if I'm asking for generating an image, it is checking the tools and see if it has any tool that can generate image, something like that. And then act. So using the tools. We will talk about what kind of acts or tools we have in the section 3. If we give examples to the agents, the first one is personal virtual assistants like Siri or Google Assistant. They can book tickets or book hotels on behalf of the user. That's why they are called agents. Or NPC characters in games. They can, if they are an AI agent, that means they are not just saying or reading a script. They can create nuanced, detailed dialogues just special for you. Or web automations, like you can create a web automation agent for maybe you want to buy something and say if the price is that low, then just buy it or just create a notification for me. This is just some of the type of agents, but of course there are a lot of examples. So in essence, an AI agent is an AI model that uses the LLM to understand the language, the natural language, and then thinking and planning it, and then interact with its environment. So the next section will be how we can give a system prompt to it. So section 2 is system prompts. System prompts, also known as system messages. They define how the model should behave. Like if it is a model for, I don't know, maybe a weather agent, then we can say that you are a weather agent and you are a professional weather assistant and something like that. For example, this is our system message, and it says raw system is like system prompt, and we are giving a content. If you are a developer, maybe you can use of system messages like you are a professional front-end developer, React developer, and you are always thinking about the test first, things like that. These are system prompts. So, for example, this is you are a barista who serves politely to the customer. This is how we are saying, okay, you are a barista and this is how you should behave. Or we can just create a crazy barista, like you are a barista who puts sugar to every coffee, even the customer doesn't want it. So system prompts also contains available tools and thought process. Like available tools are, we are saying, okay, this is how you should behave. Then this is your available tools. Like for example, for ChatGPT, you can create images or you can web search, things like that. We will talk about the tools in the next section in detail, and the thought process in the following sections as well. Thought process is, this is how you plan it and this is how you think before you act. Things like that. You can give details to the system prompts. So next thing we will talk about is chat templates. Chat templates guide us how the conversations are formatted into a single prompt. What I'm talking about is when we are talking with a chatbot, it always knows the context and answer as like we are talking with a human. But actually every time it reads the whole conversation and give an answer to us. It's how it is doing with the chat templates. For example, in this conversation, we have a user and user says, I need help with my order. It is probably talking to an assistant for a ticket, something like that. And the assistant says, I'll be happy to help. Could you provide your order number? And user says, it's order 123. So We have more than one chat templates. For example, we have small LM1, LM2 template. Like this is a starting token, and we are saying you are a system, and this is how you should behave. This is what you are. You are a helpful AI assistant named small LM, trained by Hugging Face. And this is the end of the sentence, like token. These are called special tokens. And now the user starts, and this is what the user says and things like that. And this is what kind of tokens the small LM2 has. But for example, this is the Llama 3.2 chat template, and it is saying begin of text, start header ID system and header ID, and it has today date and cutting knowledge date, things like that. And this is how the Llama 3.2 chat template actually keeps the whole conversation under the hood. If you don't know what are tokens, I have a video about tokenizers, so you can check that out in here. We have a chat template viewer. This is a Grid.io UI. Grid.io is a project of Hugging Face. It is open source, and you can create UIs for your AI models. I will give the link for the Grid UI as well. So this is chat template viewer. You can give the model to here, and you can see what the system keeps the chat template under the hood. Like for this conversation for Meta Llama, this is our conversation when we format it. As you can see, it is formatting and keeping the chat template like this. Let's give a different model to here. Let's give Hugging Face TV, small LM2, format the conversation. As you can see, it has different tokens. It keeps the whole conversation, but in a different style. Let's like it, because I like it. And if you want the templates in detail, if you want to read more, if you are interested in about it, you can read in detail in here. I will give you the link in the description as well. Our section 3 is about tools and actions. So a tool is a function given to the LLM, like web search, image generation, things like that. The popular tools are image generation, like I said, and web search, and API calls, maybe for weather API to learn weather informations. And in order to create a tool consists of a name, like what is the name of the tool, and it has a description, what is this tool is doing, because we need a concise, simple description. So an LLM knows what this tool is doing, so it can use it in the conversations. And we need to know about the inputs and outputs. For example, let's say we need to know about we want the weather information to an LLM. If we just ask an LLM what is the weather like today, and if it hasn't a tool for it, it will just create a hallucination. It will give us a wrong answer. But if it has a tool for the weather API, like the weather tool, let's say we have a function like this is of course a dummy one, like get weather info and location, and it will maybe get it from a backend API, something like that, and return the info. We can give our system prompt. If you remember, we can give our available tools to the system prompts, and to say you have these tools, we can describe it like this. Like this is our name, get weather info, and this is our description, gets weather information in detail. Our arguments, our inputs are location string, and our response is a string as well. Now our system prompt is you are a fashion stylist to recommend clothes due to weather conditions. So this is how it should behave, and this is what you are, and this is your available tools, and this is our description. Of course, we can't just write all the tools. There are a lot of tools, and we can just create the wheel again and again and again. And for this, we have a model context protocol. It is created by the Anthropic. So model context protocol is an open protocol that standardizes how application provides tools to the LLMs. We have a lot of MCPs like GitHub MCP, Postgre MCP, so we can create tools of those products. And the pros of it is it has pre-built integrations. It has the same protocol between LLMs, so it creates a standardization. And for data security, if you want to know about model context protocol in detail, I have a video about it, so you can check that out as well in there. Our section 4 is agent workflow. So how an agent behaves, like what is it doing when we ask something. This is a simple workflow, of course. So the start, like when we give a prompt, and it is thinking and reasoning. This is called a reasoning section. So it's planning to do things like I will do this, then do that, and do that. Then it starts to call maybe tools. So this is the acting section. It is interacting with the environment to maybe we want to create a ticket, a support ticket, things like that with a chatbot. Then we have an observing section, because we don't know if we use the right tool or the tool has succeeded as well. So we want something from the end agent works until it is success. So if it is failing, it will think again, say, okay, that didn't work, then I will try this or I will do this. If you are using code assistance, it is trying to generate a code and then it is trying to build it, then it is failing, or and then say, oh yeah, something is wrong, then I will try this. You can think about it like that. And then if it is success, then okay, this is the end. So now our system prompt is like this. This is how you should behave. This is your available tools. And okay, this is how you should create your workflow. You should think step by step in order to fulfill the objective with a reasoning divided into thought, action, and observation steps that can be repeated multiple times if needed. You should first reflect on the current situation using your thoughts, things like that. Then, if necessary, call a tool with the proper JSON formatting action. We will talk about action types in the following sections, in the following sentences. Or print your final answer, starting with the prefix final answer. We are saying you should always give your answer like final answer and the answer, things like that. So let's talk about the thought, actions, and observes. So, thought section. Thoughts represent the agent's internal reasoning and planning process to solve a task. If you give a detailed planning system prompts to the agent, for example, I'm using it for the code assistance. When I ask to do something, it is saying, okay, now I will do this, I will do this, I will do this, and this step. Is it okay for you? Or should I change anything? So this is the thought. This is the reasoning section. Some of the thought types are planning, like in order to make a trip planning, I will create sections for the foods and I will create sections for the history places and things like that. The second one is problem solving, like in order to solve that building issue, I just need to create that unit test first, something like that. Decision making is, okay, this is my user's budget and so I need to propose this trip agency, something like that. And maybe for memory integration, we can talk about like, okay, I can create a code like this, but I know that user mentioned months ago that it knows just React, so I will create the code in React. This is like the thought reasoning sections. And there is an approach called the React approach. It is the concatenation of reasoning and acting. So it is the mentality that before I act, I need to create the steps that I will do. Then I will act. So this is the called React approach. The next one is actions. Actions are the concrete steps that an AI agent takes to interact with its environments like the web search and API calls and things like that. So we have types of agent actions like a JSON agent. This is the agent that we are giving the orders in the JSON format. We have a code agent that generates code, like when we ask something from the agent writes the code, generate it, and give us the response. This is the code agent. And the third one is function calling agent, actually subcategory of the JSON agent, and it is fine-tuned to create a new message for every action. We have four action types like information gathering, for example, web searching or retrieving documents or querying databases. For tools usage, we can think about like generating codes and using that codes. For environment interaction, we can think like the smart houses. The agents interact with the house smart devices, and communication is agent that communicates with the user or with another agent. A code agent is an AI agent designed to write, understand, execute, and improve the code based on the goals we give it. For example, we can give a prompt like read the CSV file and calculate the average revenue per month. So an agent will import the file, write the code in a language we prefer, and handle the errors like missing values and show the result as a chart or report. This is what an agent will do in all of this. This is all will be done by an code agent. So the third section is the observing section. This is the actual measurement section. So observations are how an agent perceives the consequences of its actions. Some of the observation features are collect feedbacks like if the action has been done successfully or not, or maybe it can get the feedback from the user. We can see that if you are using ChatGPT or another chatbot, you can see that we have an successful response or failed response, something like that. So it is collecting the feedback, or it can append the result, like when it got the result, it can append the results and it can append it to its memory. So the agent now knows that this is a successful response. So it will think about it in the following sections. That is what is adapt its strategy. So it will thought and update its context to maybe it can use this tool or action in the following sections more or less. It can depend on the response. So this is the reasoning, acting, and observing sections. So now we will talk about a dummy agent library. Now why? I will talk about it in the last section. So the last sections is dummy agent library. This notebook is from Hugging Face agent course. Let me show you the course as well. So this is the AI agents course. This is actually what I'm getting the material from it as well. If you are into the AI agents, you can check this out. And the notebook is from there. So in order to run this notebook, you need to get a token from your Hugging Face account. So let's see, we have that token. So we will install the Hugging Face hub, and we will, via our token, we will inference the Meta LLM model. So we will use it as our client. There are a lot of models that Hugging Face inference it. So we have a client object, right? And in this section, we are saying text generate. So we are saying the model we are giving a prompt to the model and say the capital of the France is, and something like that. So when we get the output, it says Paris, the capital of France is Paris, the capital of France is Paris. It will always give the same response, maybe forever, or to the max token. And we need to stop it in somewhere. Why it is in a loop, like in a while section, and always giving the same response? Because this is like base model client. So in order to get a clear response, we need to create a chat template first. So now let's add a chat template. This is like we are creating our agent with an LLM. So we have an LLM, Meta LLM, Meta Llama, and now we are creating our chat template and say, okay, this is the beginning of the text, and this is the start header ID. If you remember, these are the special tokens of the Meta Llama, and the capital of France is something like that. Okay, now let's give our prompt to the model and create again. As you can see, now it just says Paris. Okay, actually, if you are using a model to use it, you don't need to actually give a chat template. You just can use the chat completions function and just give your prompt, and you can get your response like Paris, but we are just doing it for the sake of the learning. So now we have a chat template. So the second one is a system prompt. So system prompt is a bit more complex and actually contains the function description already appended. For example, we have a prompt like how you should behave, like answer the following questions as best as you can. You have access to the following tools. Now we are describing the available tools. We have a get weather, and we have name and description, and we have arguments like inputs and examples, inputs and outputs and examples. It says always use the following format, like this is the question and this is your thought section, this is how you should reasoning, this is how your action, and this is your measurement observation section. So this observation is unique, complete, or the source of truth, and says you must always end your output with the following format. This is thought, I now know the final answer, and this is the final answer, something. It should be the input section. Now we can remind you to always use the exact characters like final answer and the response. Okay, this is our system prompt. It has the behaving section, it has a tool section, and it has the workflow section. Okay, so since we are running with the text generation, we need to add the right special tokens for the Llama 3.2. Okay, since we are running the text generation, we need to add the right special tokens. Like this is our chat template and this is our input. We can't just give our input because we need to create it with our chat template, right? So this is our chat template. So when we give our chat template to the prompt, so we have the whole system prompt and the user prompt in the same section. So we have the behavior, we have the tools, we have the workflow. Now we have the chat template, like we have the conversation in our prompt. So when we run it, it says what's the weather in London. Okay, it is creating the action and says the current weather in London is mostly cloudy with a high of 12 centigrade and something. Okay, actually this is not the right answer because we didn't create the agent weather API function. So it's just creating a hallucination, like it is just giving a wrong answer. So we can just create a dummy function like get weather, something like that, and with a location. In production, of course, this can be an MCP, model context protocol tool maybe, or you can just create something custom. So this is a dummy one, but maybe in production it could be an API call or a database query, something like that. And it says the weather in location is sunny with low temperatures. Okay, now this is the right answer. Let's think about like that. When we concatenate it with our function, with our tool description or tool function, now the final answer is, okay, final answer, because we gave it like that in the chat template, if you remember. And the response is the weather in London is sunny with low temperatures. Now it is the right answer. Okay, this is how we can deal with AI agents, but it is really that kind of tedious like the templates and things like that? No. So why did I do it? Just for the sake of learning. Actually, we have frameworks, agent frameworks, and in the following videos, we will learn how it is easy with the agent frameworks. But I think this one is needed because this is what actually those frameworks are doing in the under the hood, and it is always good to know the base knowledges. So this is in a nutshell what an AI agent is. In the following videos, we will talk about AI agent frameworks. That's it for today. Thanks for watching. See you in the next video. May the force be with you.